Hi, today I'll be giving you a short introduction on freefall and terminal velocity. So the question is, why doesn't the velocity of an object free falling increase endlessly? To begin with, let's imagine a ball free falling, meaning that the gravity is the only force acting upon it. At first, gravity would obviously pull the object downwards. There would be a net force acting downwards as there is nothing opposing it, so the object will be accelerating downwards as well. As the object accelerates, air resistance will start to act on it. At this stage, it is important to look at the two forces acting on the object. Gravity or weight pulls the object downwards, and the air resistance pushes the object upwards. While the gravitational force stays constant, the air resistance depends on the velocity of the object. Also, comparing the size between the drag and the weight is still larger than the air resistance, meaning that the object will still accelerate downwards but at a smaller magnitude compared to before. As the object falls faster, air resistance increases as more air particles collide with the object. Eventually, the upwards drag force equals the downwards gravitational force. This means that the net force is equal to 0, and the object stops accelerating. This is explained when looking at the Newton's second law of motion, where force is equal to mass times acceleration. The velocity at this moment is called the terminal velocity. It is constant, no speeding up or slowing down. So why doesn't the velocity increase endlessly? You might think objects in free fall always speeds up, but that is only true in a vacuum when there is no air resistance. In real life, drag force grows with velocity until it balances gravity. Let's look at a graph of velocity versus time. Object falling in a vacuum doesn't stop speeding up. The velocity increases at a constant acceleration or rate. This is called an ideal situation. On the other hand, the object in real life where air particles do exist, the velocity reaches the terminal velocity. But what causes this drag force? It is all about the particles in the air. When an object moves, it collides with the air particles. Each of these collisions create friction, causing the object to convert its kinetic energy into thermal energy, reducing the object's ability to accelerate further. The faster it moves, it collides with more particles, increasing the air resistance. These are the factors affecting the terminal velocity. First of all, it's the mass. More mass generally means a higher terminal velocity. A bigger surface area increases the drag, lowering the terminal velocity. Lastly, the density of the fluid. Denser the fluid, lower the terminal velocity. In summary, terminal velocity happens when the drag force equals gravitational force, stopping further acceleration. This drag comes from the air particles colliding with the object, creating friction. That is why objects don't keep speeding up forever. Thank you for watching.